Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. I request you please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. Don't worry, after some time I'll give you the right answer. I believe you have tried, so let's start. So look at what is the expected final product of this reaction. Here I have taken an aromatic carbon halogen bond and that is treated with one equivalent magnesium. It's very important. Second step is dry ice, which is electrophile, and third step is obviously workup. So what is the product? In order to go the depth, you remember one thing. Aromatic halide have partial double bond character. How? Because these halogens have 3 lone pairs of electron and that could be donated inside this benzene ring. So it will open. So the canonical form is expected to look like this is double bond X with a plus charge and this ring is minus charge. Further delocalization possible. I am not drawing other canonical forms. What message? That this carbon halogen bond, this is stronger compared to aliphatic one. Why stronger? Because it has some partial double bond character too. So consequently you can expect that, sir, it is difficult to break because of this donation. Now how this donation actually affected? Based on actually orbital size. So better the orbital size match with the carbon, better is the overlap. If overlap is more, obviously bond will be strong, and if the bond is strong, it is difficult to break. Now when overlap is less, when size mismatch is there. So if you look at carbon second row, carbon bromine, it's a second row versus fourth row. Carbon fluorine second row very strong. Carbon chlorine second row, third row significantly more strong. So carbon bromine, this second row versus fourth row is actually the weakest here. So consequently this bond will be broken. So after first step, what will be the product? The Grignard reagent will be prepared here. Actually, if I say more accurately, magnesium will release 2 electrons and those 2 electrons will reduce this carbon bromine bond, and carbon will have a minus charge and magnesium, this will be a positive. So obviously magnesium plus 2 is stable. Now second step, dry ice means solid carbon dioxide where carbon atom can act as the electrophile. So these will attack, it will open. First step, it will produce carboxylic acid salt. Upon workup with dilute acid, I mean H3O plus, it will be converted into carboxylic acid. And what is the fate of magnesium? It is magnesium hydroxybromide. This is the overall product. Now reaction will stop at monosubstitution or monocarboxylate. Why? Because I have taken only one equivalent magnesium. So further reaction is not possible here. And why dry ether? Because Grignard reagents are moisture sensitive. So if moisture present, that will react with this, produce Grignard and produce aromatic hydrocarbon. That is a waste of reagent. So dry solvents, especially dry ether or dry THFs present, is essential for any Grignard preparation or reactions. Now what is the answer here? Only this carbon bromine broken, so option B is the right answer. Now other bonds will not be could not be broken in presence of carbon bromine. I have told this is the weakest, and tricarboxylic acid also not possible because one equivalent magnesium is taken. So this is the overall discussion. Here we have learned how strength of a particular bond can provide selectivity for Grignard reagent formation, and later on reaction with electrophile like dry ice. So this is the overall discussion. I believe this video will be useful. Thanks for watching. See you in my next video. Bye bye.